Hello and welcome back. Today I have another power supply, and then you think, oh, how many power supplies you need? Well, this is kind of a special power supply, and it's from PeakTech, and it's the 6120. And what is so special about this thing is that it has AC and DC. So it has 0 to 30 volts AC, 5 amps. And for DC, it has the same 0 to 30 volts, 5 amps. For if you look at it at a pure DC perspective, you think, well, it's kind of limited because I don't see a constant current, I don't see a constant voltage. And for AC, it's exactly the same. But the cool thing is that it does have AC. So I actually wonder how they done that. Because for DC, you can have all your nice stuff, all your electronics, you have nice current, constant current and constant voltage. But how we do this with AC without making a AC power source, because that would make it very expensive. No, then you just regenerate the AC. So, but if you see, there is a huge knob, and I didn't open it yet, but it really feels like this knob is directly into a transformer or something. So I'm thinking it's like kind of like those Variacs, and then they built a power supply around it or something. So well, let's first have a closer look, and of course we're going to open it. I found this again on my local eBay. They say it was hardly used, and but still they sold it way below a third or a quarter of the new price. So I think I did a good deal, and I was just very interested how they did this, because you don't find that too much, the AC power supply without it being an AC power source. So and as I said, it's from the PeakTech company, and I had PeakTech devices before. And the nice thing with PeakTech, at least with here in Europe, I think the head office is in Germany, and I had before a signal generator and a voltage meter. And if you send an email to support, if they send you the schematics or some documentation that they have. And yeah, they are not difficult about it. So that is what I like about this brand. So let's have a closer look. Well, here we have it. It seems that there are a little bit scratches, but I think it is actually because it is so new that the foil is actually still on it. I think we saw that the glue is almost off, but look. So it indeed is new. So, well, we can get that out. And, well, the voltage is just like this. Up and down. And then it's in DC or in AC. The colors are a little bit confusing. Here we have the minus is blue, the positive is red. Well, I would have preferred this one maybe to be black. The ground should be green, and then maybe this too yellow because it's AC. But they picked these colors. Okay, let's power it on. It seems like a hard switch. It is blue. Well, I'm not necessarily sure I like it blue because it is really intrusive to the eyes. And it is kind of Chinese, but it does fit the colors of the brand and the logos. This looks like some automatic fuses. It is now in DC mode, and yeah, this doesn't feel like a normal pot. It really feels like, yeah, like a Variac. And maybe that's exactly what I did. But then I also wonder how precise is it if you put load, if the voltage then drops or not. So we're going to test that. And now it should be DC. And now it is AC. AC 24.9. DC 25. I'm not sure if the outputs really go on and off, or this is just what you pick for looking at the meters. So let's have a look for that. Okay, I have a little setup, DC on the right, AC on the left, and if we switch it on, this is the AC-DC switch, sorry. If we switch it on, what do we see? Well, the 0 is almost 0. We see a little bit, but it can't go lower. So if we go higher, and I try to put it to 10 volts on the display. Well, it is 10.1 on the DC, and both the outputs are constantly on. So, and the switch here is just, we are looking at what? Okay, so here it says 10.6, and it more or less agrees here. And here it should be 10.1, and indeed, well, it also needs to be adjusted. But so we know, okay, the outputs are both always on, and it's just a little bit of a, you're just switching over the meters. So maybe we can put a big switch to switch on and off the outputs. I like that, because especially if you are adjusting now DC 10 volts, and if you want to use AC, then it is a lot higher. Okay, and it goes up, 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 up. What happens if we put it to 15 volts and we add a load? Does it drop or not? Okay, let's see what happens. Well, I'm kind of guessing that the voltage will drop, because there is no regulation or anything. It doesn't even say it's a regulated power supply. So, but it is able to do 5 amps. So I'm just wondering what will happen. And if it is indeed a variac, then I think it's kind of, you need to see it like there is a transformer, and inside that transformer is probably some sort of variac, and then on the other side is mostly just a rectifier bridge for DC and without the rectifying bridge for AC, and that is how you adjust it. So, but let's see what will happen. So there is not much regulation you can do, because the transformer is just doing its transforming, but when there is a lot of load on it, the voltage will drop. So I think that we will see that. I'm now putting 10 ohms, if my switches are correct. I think it needs to be like this. And I'm looking at the DC, which is now 15.6. And it drops indeed to 12, but it is with 4 amps. Okay, my switches were not correct. So it is indeed not regulated. 15.7, and it goes to 14.2. It doesn't drop that much, so it really can take some power, but then you can just adjust it more up. Can we make it to 5 amps? If I put all my switches, because it should be able to deliver 5 volts. Amps, hey. Ooh, look at it. Oh, there is some sort of limiting, because 2 amps, 3 amps, 4 amps. It's doing more than 5, more than 6, more than 7 amps. 8 amps, 9 amps. Oh, I think it's actually 10, but we don't see the number. Yeah, and now the fuse blew. So that works. Oh, cool. So it's totally unregulated and my resistors are burning. I think we need to, it already works. It's temperature control. Okay, cool. Okay. What happens with the AC? Well, probably the same. Put the first put to 10 volts. We put a little load. It drops a little bit. We put some more load. and it will drop some more, but it doesn't drop that much. But yeah, clearly it's unregulated, but we can go up to 10 amps. Wow. Okay, it is clearly idiot proof because it is up to 5 amps and I run it above 10 and then the automatic fuse just blow, but then after it's cooled down in 30 seconds you just push the button again and nothing happened, nothing is broken. So in that sense it's a good device. It is totally unregulated, and now we're gonna have a look inside what it actually looks like, how they did this, and what does this knob actually do. Does it have electronics or is it some kind of variant? So, well, I honestly didn't have a look inside, so I'm going to do that. I will disconnect the power, usually with the screws here, but because of its weight, and it is really some weight, these screws also need to be untied because probably there's some sort of bridge here. That's what you see with most of the power supplies. Yes, it's a long screw, so it probably was connected to that bridge. And here is another screw, so now we know for sure. Okay, that screw doesn't want to go. Now I really think we need to take that screw, but I don't think it's doing anything. No, it needs to be. No, no. No. Oh, no, 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 no. Okay. It is the ground wire. Okay. Okay, let's have a look. Okay, this is interesting. I did not expect this. It indeed has some sort of variac on the right here, and it seems that they only use this for the AC, because for the DC they have a very expensive transformer. How is that, a Ceroid, or I forgot the name? We call them ring transformers. But I think there is a luxury name like Ceroid, or I forgot. But these transformers are not cheap, so, and they use too. So I'm actually a little bit surprised. Well, here we have a look from the other side, the DC part, and the DC part is, well, sort of straightforward. Now the big transformer goes to the bridge rectifier. I see a relay here. That I don't know why. Maybe at a certain voltage it switches up or down, or it just switches off when the current limit is there. And that is all the electronics there is. And there is, yeah, I think that is a very, very small transformer. It's 2200 microfarads, 50 volts for 5 amps. I'm not sure. I would expect for 5 amps at least something here also with the 5, like 5000 if it doesn't exist. So it's 60, 80, 68 probably. I would have expected there. So this is not made for fine electronics, but yeah, also we didn't expect that because there was no constant voltage and constant current controls, although they could have done that in the DC part. But as less as electronics as possible, then there is also as less as possible that can break. And we do see some electronics here in the front, but this is purely for the voltage meters. And I did. There are 4 pots here, and the support from PeakTech did send me exactly which pot does what for measuring. Well, that was nice to have a look inside. There are a few improvements that I want to do, and one is very simple. This knob is not in the middle, because here you can hardly see, and here there is an edge. Let me show you closer by. Here we can clearly see that the knob is not in the middle, but it is directly inside the transformer right there. So I think if we loosen the screws, position it better, that is already solved. Also the colors that I really don't like. The blue, it should have been black. This one should be green, and these two can then be yellow. And I ordered once in AliExpress these things, so I have all the colors. So the green can be the green one, and then here we have 2 yellows, and I think the colors are just better then. So let me see how easy that is. First we start with the knob here. Well, I'm looking a bit closer at the design, and it is actually really straightforward, because all the electronics that are in there is just to control the voltage and the amp meter, because it doesn't do anything. So this big ring transformer that we have, that's just this one, and if you connect it directly to the mains, then it just provides the 30 volts AC here, or DC through the bridge rectifier, and a little cap that I have. It is too low, I would make it bigger, and that's your DC, and that's all it is. And then they have this little variac, but that is just put in front of this ring transformer. So this is also low power or low current, because this is the primary side of the transformer, so the currents are very low on this side, except here is 5 volts, but as you can see it's almost divided by, well, it's a little bit less, but make it simple, it's divided by 10, so if we have 5 amps here, it's an half ampere, so it's like, I don't know, if we have 200 volts here, half an amp, so this one is just a 150 watts variac, so that's very low. So in that sense, it is a smart design. And but it also opens possibilities, because this whole part is that simple. If I want to make something that is adjustable from 0 to 15 volts, I can also just put here 110 volts instead of 230, and then I can do very low AC voltages. For the DC it's not that interesting, but if you're looking for some sort of AC power source that can do very low voltages, you just put here a very low voltage. And if you have a 110 volt converter, you could connect it here, and then you are already from 0 to 15 volts, and then you can measure very precise. But also, if maybe you want to go to 60 volt, the only thing you need to be careful about is this gap here. So make sure this one can do up to 100 or 200, doesn't matter too much, just make sure it's enough. And then if you change this transformer, you can go a lot higher in your AC, or you just take out the whole DC part. If you're not interested about that and you're looking for some sort of cheap AC power source, this one would be easy to adjust. So as I said, it opens a lot of possibilities. It is a nice device, and I will keep it, because maybe I want a low voltage AC power source, and then this is a lot safer. than having a huge AC power source that can go up to 300 volts. And then in the lower voltages, it will be harder to adjust. It will be less precise. And then here you have really the variac. And maybe if I put different transformers in it, maybe if I put a smaller ring in it, I can adjust the voltages much more precise. And as I said, maybe if I put it on 110 volts, I can also adjust very low. So, and what I want to do is also change the plugs. I won't do that now. I cannot get the plug off. I don't know if there is a cap here. And because if I pull it, I just see the whole transformer move for the variac. So I don't want to do it. I'm not sure if this cap can maybe be taken off. Oh yes, it can. That's why it's stuck. And then I can take the front off and replace the plugs. And also center it a little bit better. And also maybe put a plastic ring, because now this is all moving. And if you have a look, this is all moving. And that is not necessary, because if you put a little, the hole is just too big. So if I put a little plastic or a nylon, and then it is just stuck. And then if you move it also doesn't, because at some point I think the variac will not like it too much if this moves. So they could have put a little piece of nylon in there, and then it is nicely stuck. Let me take it out. I want to show you, because that is really where they missed out there, and it was not necessary. So yeah, this is a huge hole, and that's why this is all moving, and then in the end you're just moving the whole variac inside. So just by putting here a little plastic, and this will keep it in its place, and then it doesn't move at all. And maybe it was like that and it got lost, or maybe just they didn't want to spend those last 10 cents. It's a pity, because it would make it feel a lot better, and also the pin will stay centered. It just looks better if they did it like that. So still some little modifications to do, but I really like it. It has some nice possibilities. And I'm just gonna play with it, and because it is very rare that you have a low voltage power source. You cannot change frequency, you cannot do very special things, no constant current, no constant voltage, but still this one goes, I think, if you buy it new, 350 euros. And it's probably because of this ring transformer and this variac that make it expensive, because the rest, there is not too much electronic. Yeah, the voltage meters, but if you have those giant thingies, then that is also a few euros. But the casing looked strong. They did a good job on that. I like this. Indeed, the bridge on top, but it is necessary because it is heavy. And I think it's a nice addition. Thank you for watching, and hope to see you next time.